Azure 203, Azure 204 develop event-based solutions. In this video, we are going to cover Azure Event Grid, Azure Event Hubs, Azure Notification Hubs. Really interesting topics because often we get confused between Azure Event Grid, what is Azure Event Hub, then, and what is Azure Notification Hub. So we really get confused between these three, and also these are really important in day-to-day life perspective. If you haven't come across me, I'm Nitesh Sharma. I'm going to take you to your Azure journey. Please like, share, and subscribe these videos if you are interested in getting Azure certifications or getting Azure knowledge, as well as C#.NET knowledge. I'm also doing videos on C#.NET. So let's get started. Lesson 1, which is about Azure Event Grids. In this lesson, we will cover Event Grid, schema, security, filtering, authoring custom events. So very nice topics about Event Grid. Let's go. So what is event driven architecture? Because in an event driven architecture, events are delivered in nearly real time so that consumers can respond immediately to events as they occur. Because event driven, if your architecture is event driven, then you are almost real time, not real time actually, because you are not really replying in real time. You might have some delays in your response, so you are not really real time but almost real time. An event driven architecture can use a pub or subs model or an event stream model. So publication or subscription based. Pub sub, the messaging infrastructure keeps track of subscription. When an event is published, it sends the event to each subscriber after an event is received. It cannot be replayed, and new subscribers do not observe the event. So you understand, once an event is published, it sends the event to each subscriber only. It does not send to the new subscribers. It's obvious, but you can sometimes get confused. And then you have event streaming. Events are written to a log. Events are strictly ordered within a partition or durable. Clients don't subscribe to stream. Instead, a client can read from any part of the stream. The client is responsible for advancing its position in the stream. That means that a client can join at any time and can replay events. So you have two things: publicity, pub sub, and you have event streaming. On the consumer side, there are some common variations: simple event processing, complex event processing, and event stream processing. So you have, let me make it a laser pointer. So here you have consist of event producers that generate a stream of event and event consumers that listen to those events. Then events are delivered nearly real time so that consumers can respond to those events immediately. And then you have common implementation include single event processing, complex event processing, and event stream processing. Simple event processing: an event immediately triggers an action in the consumer. For example, you could use Azure Functions with a service bus trigger so that a function executes whenever a message is published to a service bus topic. Same way, you have complex event processing. A consumer processes series of events observing patterns in the event data by using a technology such as Azure Stream Analytics or Apache Storm. You could aggregate readings from an embedded device over a time window and generate notification if the moving average crosses a certain threshold. So it's like as you analyze a series of event, and then after processing or observing those events, you trigger an event. You trigger an action. So you don't trigger just like this, but you just wait for it to cross certain threshold. So complex event processing, you wait for certain threshold and then you trigger an action. Event stream processing, use the data streaming platforms such as Azure IoT Hub or Apache Kafka as a pipeline to ingest events and feed them to stream processors. The stream processors act to process or transform the stream. So there may be multiple stream processor for different subsystems of the application. So it's clear for you, I guess. You have three types of common implementations: single event processing, complex event processing, and event stream processing. In the same way, to be continued in the event-driven architecture. An event-driven architecture consists of event producers that generate a stream of events, as I already said, event producers, and event consumers that listen to the event. So producers are decoupled from consumers. A producer doesn't know which consumers are listening. Consumers are also decoupled from each other, and every consumer views all of the events. This differ from a competing consumer patterns, where consumers pull messages from the queue and a message is processed just once, assuming no errors. In some systems such as IoT, events must be ingested at very high volume. So here you see the dependency. There is no dependency between event consumer and event producer. Event producers are sending events to event ingestion, and event consumers are waiting for event ingestion to fire an action so that event consumer can consume it. In this diagram, if you see, each type of consumer is shown as a single box. In practice, it's common to have multiple instances of a consumer to avoid having the consumer become a single point of failure in system. To have a good architecture and a good architecture, that's a common practice that you have multiple listeners to your events, so that if let's say if it fails, then whole system is a failure, because in the end you didn't do the action, so that's none of your use then. So now let's talk the real thing now. Azure Event Grid. What is Azure Event Grid? So you can use Azure Event Grid to simplify your event-based apps with Event Grid, a single service for managing routing of all events from any source to any destination, designed for high availability, consistent performance, and dynamic scale. Simplify event delivery, build reliable cloud applications, focus on product innovation. So what is Azure Event Grid? Still, I haven't answered the question. Azure Event Grid allows you to easily build applications with event-based architecture. So first select Azure resource that you would like to subscribe to and then provide the event handler or webhook endpoint to send the event to. Event Grid has built-in support for events coming from Azure services like storage blobs and resource groups. Event Grid also has support for your own events using custom topics, and you can use filter to route specific events to different endpoints, multicast to multiple endpoints, and make sure your events are reliably delivered. So even an Azure Event Grid allows you to easily build applications with event-based architecture. It has built-in support for events like coming from Azure services like those for Azure Blob Storage and Resource Group. And these are the following services that can send events to Event Grid. So what is if we talk in real life example, let's say you want to have an application which is responsive to your blob storage. Let's say your client uploads an image and you want the image is really a big image, then you want to create thumbnails out of it and you want it to be done automatically. So whenever your client uploads their image, you want to create thumbnail out of it so that you can use them in their profile pictures. Simple, right? So for that you can create an event grid. So whenever client uploads an image to their Azure storage, you can fire an event, and so you can add a listener or consumer. So webhook, you can create a webhook which will listen to this event. So your webhook will be your consumer and webhook will create a thumbnail out of it. Simple, right? So sources and handlers. An event source is where the event happens. Several Azure services are automatically configured to send events. You can also create custom applications that send events. Custom applications don't need to be hosted in Azure to use Event Grid for event distribution. An event handler is the place where the event is sent. So the handler takes some further actions to process the event. Several Azure services are automatically configured to handle events. You can also use webhook for handling events. As I just said in my example, the webhook doesn't need to be hosted in Azure to handle events. Event Grid only supports HTTPS webhook endpoints. So you have your sources and you have different type of sources, event sources. And you see here you have blob storage, media services, Azure subscriptions. Azure subscriptions mean if anything happened to your Azure subscription, fire an event. Resource group, same way. If any resource is created in a resource group, then you can fire an event. Same way, event hubs, IoT hub, service bus, custom topics. So you see you have a lot of possibilities here, and you can automatize your processes and enjoy. So event grid concept. What is an event? Event is the smallest amount of information that fully describes something that happened in the system, right? Event, what is event is what happened. So every event has common information such as source of event, time the event took place, and the unique identifier. Every event also has specific information that is only relevant to a specific type of event. For example, an event about a new file being created in Azure storage has details about the file such as last time modified value, or an event hubs event has URL of the captured file. Each event is limited to 64 kilobytes of data. So event itself has some information about itself. like some information about it, actually metadata you can say. Then you have event sources. The event sources where the event happened. So each event source is related to one or more event types. For example, Azure Storage is the event source for blog created event. IoT Hub is the event source for device created events. Your application is the event source for custom events that you define. Event sources are responsible for sending events to the event grid, right? So because event itself cannot be sent, right? Event is simply an entity. You need someone to send that an entity to a event grid. Then you have topics. The event grid topic provides an endpoint where the source sends the event. The publisher creates the event grid topic and decides whether an event source needs one topic or more than one topic. The topic is used for a collection of related events to respond to certain type of events. Subscribers decide which topic to subscribe to. System topics are built-in topics provided by Azure services. You don't observe system topics in your Azure subscription because the publisher owns the topics, but you can subscribe to them. To subscribe, you provide information about the resource that you want to receive events from. Then you have event subscriptions. A subscription tells Event Grid which event on a topic you are interested in receiving. So you can decide, right, what you want to receive. When creating the subscription, you provide an endpoint for handling the event. You can filter the events that are sent to the endpoint. You can filter by event type or subject patterns. Then in the end, you have event handlers, which is the fifth but most important. From an event grid perspective, an event handler is the place where the event is sent. The handler takes some further actions to process the event. Event grid supports several handlers types. So you can use supported Azure service or your own webhook as the handler, and you can have multiple handlers for a single event. Event grid follows different mechanisms to guarantee the delivery of the event. For HTTP webhook event handlers, the event is retried until the handler returns a status code of 200 OK. Next is event grid concepts continue. An event source is where the event happens, as we already talked. Several Azure services are automatically configured to send events. You can also create custom applications that send events. Custom applications don't need to be hosted in Azure to use Event Grid for event distribution, right? So you can have this is your event, this is your source. So your source is you not necessarily have to be on Azure. It can be hosted anywhere, and you can send your events from there to the event grid. The event grid topic provide an endpoint where the source sends events. An event handler is the place where the event is sent at the end. The handler takes some further actions to process the event. Several Azure services are automatically configured to handle events. So now you send the event, and then your event subscription, based on your event subscription, handler is decided, and then it is sent to the handler, which we already discussed. Schema. Event consists of a set of 5 required string properties and required data types. The properties are common to all events from any publisher. The data object has properties that are specific to each publisher. For system topics, these properties are specific to the resource provider, such as Azure Storage or Azure Event Hubs. Event sources send events to Azure Event Grid in an array which can have several event objects. When posting events to an event grid topic, the array can have a total size of up to 1 megabyte. Each event in the array is limited to 64 kilobyte, which we already talked. If an event or the array is greater than the size limits, you receive the response 413 payload too large. Because generally you don't need that much information to send. You only send these things, right? Topic, subject, ID, event type, event time, data version, and metadata version, right? So you don't send that much information. Blob storage event. This is the example specific implementation of event related to Azure Blob Storage, where you have information like topic, event type, blob created, event time, ID, data, what is the data, and data has some more information which is used by the event grid later on, data version and metadata version. Schema event properties. All events have the same top level data. For custom topics, the event publisher determines the data object. The top level data should have the same fields as standard resource defined events. When publishing events to custom topics, create subject for your events that make it easy for subscribers to know whether they are interested in the event. Subscribers use the subject to filter and route events. Consider providing the path for where the event happened, so subscribers can filter by segments of that path. The path enables subscriber to narrowly or broadly filter events. For example, if you provide 3 segments path like A, B, C in subject, subscribers can filter by the first segment A to get a broad set of events. Those subscribers get events with subjects like A, B or ADE. Sometimes your subject needs more detail about what happened. For example, storage accounts publisher provides the subject, blob storage, default container, blah blah, and the place where it should be. And event type should be one of the registered event types for this event source. Event time, the time event is generated based on the provider's UTC time. ID, unique identifier for the event. Data, which we just said, this whole information about the data version, and metadata version, the schema version of the event metadata. Security, very important. Webhook event delivery. Webhooks are one of the many ways to receive events from Azure Event Grid. When a new event is ready, Event Grid service posts an HTTP request to configure the endpoint with the event in the request body. Like many other services that support webhooks, Event Grid requires you to prove ownership of your webhook endpoints before it starts delivering events to the endpoint. This requirement prevents a malicious user from flooding your endpoint with events. Of course, you want to have a secure endpoint. When you use any of the 3 Azure services like Azure Logic Apps, Azure Event with Event Grid, Azure Event Grid Connector, Azure Automation via Webhook, Azure Functions with Azure Event Grid trigger. The Azure infrastructure automatically handles this validation. So Azure takes care of your security authentication. Event subscriptions. To subscribe to an event, you must prove that you have access to the event source and handler. Proving that you own a webhook was covered in the preceding sections like we just talked about. If you're using an event handler that isn't a webhook such as an event hub or queue storage, you need with access to that resource. This permissions check prevents an unauthorized user from sending events to your resource. So you must have the Microsoft Event Grid event subscription, the right permissions on the resource. These permissions. There on the resource, that is the event source. You need this permission because you are writing a new subscription at the scope of the resource. The required resource differs based on whether you are subscribing to a system topic or custom topic. Both types are described in these sections. Custom topic publishing. Custom topics are either shared access signatures, SaaS, or key authentication. SaaS is recommended, but the key authentication provides simple programming and is compatible with many existing webhook publishers. Now you have filtering. Event type filtering. By default, all event types for the event source are sent to endpoint. You can decide to send only certain event types to your endpoint. For example, you can get notified of updates to your resources but not notified for other operations like deletions. In that case, filter by Microsoft resource.write success event types. Provide an array with the event types. Specify all to get all event types for the event source, so you can filter it easily. For simple filtering by subject, specify a starting or ending value for the subject. For example, you can specify that the subject ends with .txt to get only events related to uploading a text file to storage account. Or you can filter the subject begin with blob services default container blah blah. So you see here you can filter with this name or repository name details. You can also have advanced filters where the operator type number greater than or equal to data.key blah blah. So you can really filter it based on your event. Authoring custom events. So what you need to do to author custom events, you need to create a resource group. You create a resource group, you register the provider and check the status. You replace you create the topic name and you create the custom topic. So to create a resource group, you just need to use age add group create -- name grid resource group location west US2 whatever the location is. Then you enable event grid as resource provider. If you haven't previously used event grid in your Azure subscription, you might need to register the event grid resource provider because it is not available directly, so you might need to register it. And then you can create a custom topic. Simple. In the same continuation, you can subscribe to the custom topic. You subscribe to an event grid topic to tell event grid which events you want to track and where to send those events. This example subscribes to the custom event that you created and pass the URL from your web app as the endpoint for event notification. So you see here on your website, and then you subscribe to the custom topic, Azure Event Grid, event subscription, create grid resource group, which was the group, and this is the name of the topic name, and then name of this subscription, which is demo of your subscription, and then the event group, the endpoint. Easy. Event handling services. An event handler is the place where an event is sent. The handler takes some further actions to process the event. Several Azure services are automatically configured to handle events. So you can also use webhook handling events. Webhook doesn't need to be hosted on Azure, as I have already said multiple times. So you have those events, then you have the event grid, then this event grid is these event handlers subscribe to this event. So maybe you have serverless, which is Azure function, which can subscribe to any of these events. Same way you can have logic apps, you have other buffering and competing consumers, other services, other applications. You have your own custom webhook. Event domains. An event domain is a management tool for large number of event grid topics that are related to the same application. You can think of it as a meta topic that can have thousands of individual topics. Let's say you run a company, construction company machinery, where you manufacture some trucks and digging equipment and other heavy machinery. As part of the running the business, you push real-time information to customers about equipment maintenance, system health, and contact updates. All of this information goes to various endpoints, including your app, customer endpoints, and other infrastructure that customers have set up. Event domains allow you to model your construction machinery as a single event entity. Each of your customer is represented as a topic within the domain. Authentication and authorizations are handled by Azure Active Directory. Each of your customer can subscribe to their topic and get their events delivered to them. Managed access through the event domain ensures that they can only access their topic. So you see, everything is handled for you very easily. You have the event domain endpoint, then you have using the Azure Active Directory, you get your event, and you are checked if you are authorized to use it or not, and then your application can subscribe to those events. So you see, you have these domains, different construction company, Northwest Builder, Redmond Construction and Construction Company, and all of these three have different domains. So event domains, you have a single output for event domain endpoint, which can send to these three construction companies. Create a custom event by using the Azure CLI. So in this lesson, we must use Azure CLI to create a custom topic, subscribe to the custom topic, and trigger the event to view the results. Typically, you send events to an endpoint that processes the event data and takes action. To simplify things, you should send the event to web app and collect the display's message. So in this demo, we should enable the Event Grid resource provider in the Azure CLI. Create a custom topic using CLI. Subscribe to the custom topic. Send a sample event to the custom topic. So as we already saw here, you can create your custom event here like this using this query. Please pause this video if you want to, so that you can see the commands, or you can use online help as well. But the idea is you create your custom topic using CLI. You subscribe to this custom topic using these commands, and then you test it by sending a sample event to this topic, so that you can trigger the topic, and then this topic, and then your webhook receives the notification or event. Right? I hope you can do it. Okay, so let's move to the next lesson, which is Azure Event Hubs. Azure Event Hubs. In this lesson, we will cover Event Hubs, capture, security model, creating Event Hubs by using Azure CLI, and programming guides. Let's go. Azure Event Hub is a scalable event processing service that ingests and processes large volume of events and data with low latency and high reliability. So Azure Event Hub can store events, data, or telemetry produced by distributed softwares and devices. Then it provides a distributed stream processing platform with low latency and seamless integration with data and analytics services inside and outside of Azure. Then it has these 5 key components: event producers, partitions, consumer groups, throughput units, and event receivers. So what is Azure Event Hub? In simple words, a big data streaming platform and event ingestion service. Azure Event Hubs is a big data streaming platform and event ingestion service. It can receive and process millions of events per second. So data sent to Event Hub can be transformed and stored by using any real-time analytics provider or batching storage adapters. So let's say you have live dashboarding, archiving data, transaction processing, user telemetry processing, device telemetry processing. So why should you use Event Hubs? So because data is valuable only when there is an easy way to process and get timely insights from data sources. Event Hubs provides a distributed stream processing platform with low latency and seamless integration with data and analytics services inside. Sorry, I need a Coke. So I think you also need a break. Anyway, we can continue now. I have my energy. Event hubs represent the front door for an event pipeline, often called an event ingester in solution architecture. So let's continue actually. Event publishers. Event Hub namespace provides a unique scoping container referenced by its fully qualified domain name in which you create one or more event hubs or Kafka topics. Event publisher: any entity that sends data to an event hub is an event producer or event publisher. Event publisher can publish events by using HTTPS or AMQP or Kafka 1.110 or later. Event publisher use SaaS token to identify themselves to an event hub. So you are a event publisher, and then you use a SaaS token to be identified by the event hub. Publishing an event: so you can publish an event by using AMQP 1.0, Kafka 1.0 or later, or HTTPS. Event hubs provide client libraries and classes for publishing events to an event hub from .NET clients. For other runtimes and platforms, you can use AMQP 1.0 client, such as Apache Cupid. You can publish events individually or batched. A single app publication has a limit of 1 megabyte regardless of whether it is single event or a batch. Publishing events larger than this threshold results in an error. As same way for Event Grid, you have limit for 1 megabyte and generally it's 64 kilobyte. Partitions. Event hubs provide message streaming through a partition consumer pattern in which each consumer only reads a specific subset or partition of the message stream. This pattern enables horizontal scale for event processing and provides other stream-focused features that are unavailable in queues and topics. A partition is an ordered sequence of events that is held in an event hub. A newer event arrive, they are added to the end of the sequence. A partition can be thought of as commit log. Right? Event hub retains data for configured retention time that applies across all partitions in the event hub. Events expire on the time basis. You cannot explicitly delete them because partitions are independent and contain their own sequence of data. They often grow at different rates. The number of partitions is specified at creation and must be between 2 to 32. The partition count is not changeable, so you should consider long-term scale when setting partition count. Partitions are a data organization mechanism that relates to the downstream parallelism required in consuming applications. Understand? The number of partitions in an event hub directly relates to the number of concurrent readers you expect to have. You can increase the number of partitions beyond 32 by contacting the event hub's team. So it's a really difficult task if you have to contact them. So better don't do it, plan it in advance. Consumer groups. So as we saw here, if you remember, you have event producers, partitions, consumer groups, throughput units, event receivers. So we are now on consumer groups. Consumer groups. The publish subscribe mechanism of Event Hub is enabled through consumer groups. A consumer group is a view state, position, or offset of an entire event hub. Consumer groups enable multiple consuming applications to each have a separate view of the event stream and to read the stream independently at their own pace and with their own offsets. In a stream processing architecture, the downstream application requests to a consumer group. If you want to write event data to long-term storage, then that storage writer application is a consumer group. Complex event processing can then be performed by another separate consumer group. You can only access partitions through a consumer group. There is always a default consumer group in an event hub, and you can create up to 20 consumer groups for a standard tier hub. And there can be at most 5 concurrent readers on a partition per consumer group. So capture. Event Hub is a time retention durable buffer for telemetry ingress. Similar to distributed logs, the key to scaling in Event Hub is partitioned consumer model. Each partition is an independent segment of data and is consumed independently. Over time, this data ages off based on the configurable retention period. As a result, a given Event Hub never gets too full because you need to get rid of some data or some partitions to have space for new partitions. Event Hubs capture enables you to specify your own Azure Blob Storage account and container or Azure Data Lake store account, which are used to store the captured data. These accounts can be in the same region as your Event Hub or in different another region, adding the flexibility of Event Hub capture feature. Capture windowing. So data is stored by using a naming convention, and naming convention is namespace, event hub, partition ID, year, month, day, hour, minute, and second. So you see, it can be like my storage account, blob core blah blah windows.net, then my container, my namespace, my event hub, then partition ID, then year, month, day, hour, minute, and time, and then AVRO. So it is a captured data of your event. Security model. As in Event Grid, same way in Event Hub, client authentication. The Event Hub security model is based on a combination of SaaS token and event publishers. An event publisher defines virtual endpoint for an event hub. The publisher can only be used to send messages to an event hub. It is not possible to receive messages from a publisher. Typically, an event hub employs one publisher per client. All messages that are sent to any of the publisher of an event hub are enqueued within that event hub. Publisher enable fine-grained access control and throttling. So only clients that present valid credentials can send data to an event hub, and they use a combination of SaaS token and event publishers, which is a virtual endpoint, and publishers can send but not receive the message. A client cannot impersonate another client. Each client has a unique token. to have to distinguish between different clients. A rogue client can be blocked from sending data to an event hub. So clients don't have access to the signing keys, thus preventing impersonation of another client. So you see the security is really tight. You cannot do much. All tokens are signed with a SAS key. Typically all tokens are signed with the same key. Clients are not aware of the key. This prevents other clients from manufacturing tokens. Creating a namespace manager by using the root key. When creating an event hub namespace, the service automatically generates a 256-bit SAS key named root managed shared access key. This rule has an associated pair of primary and secondary keys that grant, send, listen, and manage rights to the namespace. You can also create additional keys. It is recommended that you produce a key that grants and sends permissions to a specific event hub. So you can create like this. You have your service namespace manage key, namespace manage key. This is the name and this is the key. Then you create the URI, service bus environment, create service URI using service namespace, and then you create the token provider using create shared access signature token provider using your namespace keys. And after you have both of them, then you can create the namespace manager using namespace URI, namespace manage token provider. To create a SAS key, you create an event hub with SAS rule to enable sending to the event hub. Let's say you say partition count 32, so you say event hub description with the name of the event hub, and then you say event hub send key name, send key, and then you use this information shared access authorization rule. With the shared access authorization rule, you can authorize your ED which is event hub description, ed.authorization.add event hub send rule, which you create right now like this, and then you create an event hub. So like here you created the namespace, here you created the ed, and you created the event hub. Same way you can create event hub using the Azure CLI. So for that you need to create first the Azure resource group, then you create the Azure Event Hub namespace, Azure Event Hub namespace, create name of the namespace, and then resource group and the region. You can pause this video if you want to watch. Create an event hub, and then you can create the event hub like using Azure Event Hub. Event hub create, here you created namespace, same way you create the event hub. That's just the difference. Creating event hubs by using Azure CLI. So I hope you can do it now. I don't have a demo. I don't want to give you a demo actually, because you should know by now how to create event hub using Azure CLI. But to give you a hint, you just need to create a namespace and hub for your event grid, then subscribe to the Azure subscription level events, subscribe to resource specific events. So you need to create event hubs, namespace, and then event hub. and then you need to subscribe to Azure subscription level events. You can have whatever you want as a condition, and then you subscribe to resource specific events. So I hope you can do it, and good luck. Let's go to next one, Azure Notification Hubs. In this lesson we will talk about push notifications, notification hubs, shared access, signature, security, device registration, registration templates. Let's go. Push notifications. Push notifications is a form of app to user communication where users of mobile apps are notified of certain desired information, usually in a pop-up or dialog box. Users can generally choose to view or dismiss the message. Choosing the former opens the mobile application that communicated the notification. Push notifications are vital for consumer apps in increasing app engagement and usage, and for enterprise apps in communicating up-to-date business information. It's the best app to user communication because it is energy efficient for mobile devices, flexible for notification senders, and available when corresponding applications are not active. So it's a win-win situation for everyone. So it's delivered through a platform specific infrastructure called Platform Notification System, PNS. We will talk about it. A form of app to user communication where users of mobile apps are notified of certain desired information. These examples include Apple Push Notification Service, APN, Firebase Cloud Messaging, FCM, Windows Push Notification Service, WNS. So depending on your OS operating system, you have different type of notification services. Apple push notification service, Firebase cloud messaging, Windows push notification services, and depending on these three services, you have different way of implementing it. Push notification services. Push notifications are delivered through platform-specific infrastructure called Platform Notification System (PNS). They offer basic push functionalities to deliver a message to a device with a provided handle and have no common interface. To send a notification to all customers across the iOS, Android, or Windows version of the app, the developer must work with different type of notification services which we talked here, because it depends on your type of your device, if it's Apple or other Windows or Android. At high level, this is how push notification works. The client app decides it wants to receive notification, hence it contacts the corresponding PNS to retrieve its unique and temporary push handle. The handle type depends on the system. For example, WNS has URI while APNS has the tokens. Then the client app stores this handle in the app backend or provider. Then to send a push notification, the app backend contacts the PNS by using the handle to target a specific client app. The PNS forwards the notification to the device specified by the handle. So you see, push notification, PNS contacts the device contacts the backend, and the backend stores the URL. Then backend simply contacts the PNS to send the notification. It doesn't directly send it to the device, and PNS send it to the device. The challenge of push notifications. PNS are powerful, however, they leave much work to the app developer to implement even common push notification scenarios such as broadcasting push notification to segmented users. Push notification require complex infrastructure that is unrelated to the application's main business logic, and these are like platform dependency, scaling, routing. So these three problems are basically main problems about push notifications. Notification hubs. Azure Notification Hubs provide an easy to use and scaled out push engine that allows you to send notifications to any platform like iOS, Android, Windows, Kindle, Baidu, from any backend, cloud, or on-premise. Notification Hubs works well for both enterprise and consumer scenarios. Here are few examples like send breaking news notification to millions with low latency, send location-based coupons to interested users segments, send event-related notifications to users or groups for media, sports, finance, gaming applications, push promotional contents to applications to engage and market to customer, notify users of enterprise events like new messages and work items, send codes for multi-factor authentications. So these are the usual. What is notification hub? It automates many of the manual tasks to work with post notification service, can tag recipients to send messages only to specific people, can create templates to automate converting a standard message into each specific application platform's XML or JSON, can send notifications from backend code to hub and then eventually to the client device. Notification hub example. So in the previously we did not have the notification hub. Now we have the client app wants to receive notification, hence it contacts the corresponding PNS to retrieve its unique temporary push handle. The handle type depends on the system. For example, WNS has URI while APNS has token. The client app stores this handle in the backend of the provider, and then if the backend wants to send notification, it will send it to the notification hub, and then notification hub will send it to the push notification service, and then push notification service will forward the notification to the device specified by the handle. Security. For security, you have shared access signature, SaaS security. Notification Hub implements an entity-level security scheme called SaaS. This scheme enables messaging entities to declare up to 12 authorization rules in their description that grant rights on that entity. Each rule contains a name, a key value, secret, shared secret, and set of rights as explained. When creating a notification hub, two rules are automatically created, one with the listen right that the client app uses and one with the all rights that app backend uses. When performing registration management from the client app, if the information sent by notifications is not sensitive, for example weather updates, common way to you access the notification hub is to give the key value of the rule listen only access to the client app and to give the key value of the rule full access to the app backend. So it depends actually on your situation. That depends. That's why you can do depending on your situation. Yeah. So device registrations. A registration associates a PNS handle for a device with tags and possibly a tag template. PNS handle could be a channel URI, device token, or GCM registration ID. Tags are used to route notifications to the correct set of device handles. Azure Notification Hub supports a maximum of 60 tags per registration. An installation is an enhanced registration that includes a bag of push-related properties. It is the latest and best approach to registering your devices. However, it is not supported by client-side .NET SDK notification hub or backend operations yet. This means that if you are registering from client device itself, you would have to use Notification Hub's REST API approach to support installation. If you are using backend service, you should be able to use Notification Hub SDK for backend operations. Creating or updating an installation is fully idempotent, so you can retry it without any concern about duplicate registrations. So you don't have to worry about duplicates. And then installation, advanced registration that include a bag of push properties, fully idempotent, so you can retry multiple times. Each installation has a unique ID that can be used to push messages to specific device. You can perform a partial registration update if you want to change some properties of the existing registration without having to rebuild the entire registration. Registration template. So template enables a client application to specify the exact format and content of the notifications it wants to receive. And template allows you to create a single message and have it transformed by notification hubs to create a platform agnostic backend, notifications personalized by device location or users, client version independence, and localization of the text content. Notification hub payload. The standard way to send push notifications is to send for each notification that is to be sent a specific payload to platform to PNS. For example, to send an alert to a PNS, the payload is JSON object of this form, which has APS alert hello. To send similar toast message on Windows Store application, the XML payload is like this: toast visual binding templates, toast text 01, and then you have like this text hello. So you can create similar payloads for Microsoft Push Notification Service MPNS or FCM for Android, and you have to follow certain structure for that. Registration template example, here you see platform independent message, which is message hello, and then for APNS template you say like this, MPNS you say like this, and just reuse the message, dollar message here, dollar message. You see, template expression language. Templates are limited to XML or JSON documents for document formats. Also, you can only place expressions in particular places, for example, node attributes or values for XML or a string properties. But you cannot, like here we used message as a variable. And so if you say $prop, reference to an event property with the given name. If you say $prop n, as above, but text is explicitly clipped at n characters. .prop n as above, but text is suffixed with 3 dots as it is clipped. %prop similar to $name except that the output is URI encoded. Hashtag prop used in JSON template, for example for iOS and Android templates. Text or text A literal content contain arbitrary text enclosed. Yep, I need to change it back to ledger. Template expressions. So this is a template using a variable name which was declared before. Tags. Notification tag. To tag expressions enable you to target a specific set of devices, or more specifically registrations. When sending a push notification through notification hubs, a tag can be any string up to 120 characters containing alphanumeric and the non-alphanumeric characters. The example shows an application from which you can receive post notifications about specific music groups. In the scenario, a simple way is to route notifications to label registration with tags that represent the different artists. So you see here, notification to tag artist 1. Notification hub will receive it, and then notification sent for tag artist 1. Same way you can just divide them. Another way of dividing it. Target devices by using a tag. So notification outcome in the beginning it's null. Then you have the tag as artist. You create the toast. Then outcome will be await notifications instance hub dot send Windows native notification. This is for WNS toast with this tag. You can also use expressions in the tag. So tag expressions. There are cases in which a notification has to target a set of registrations that is identified not by a single tag but a boolean expression on tags. So you can have multiple tags and calculated using a boolean expression. So consider a sport application that sends a reminder to everyone in any town about a game between hometown and visiting team. If the client have registered tags about interest in teams and location, then the notification should be targeted to everyone in any town who is interested in either the hometown or visiting team. This condition can be expressed with a boolean expression. Simply you can combine multiple multiple conditions to send the notification. It's simple. So you can also use location. You see tag expression examples. So heavy. There are cases in which notification must target a set of registrations that is identified not by a single tag but a boolean expression on tags, as we already talked about. Consider this application which sent reminder to everyone in any town about a game between hometown and visiting team. If the client have registered tags about interest in teams and locations, then notifications should target everyone specified town who is interested in either team. So you say follows home team or follows visiting team and location any town, then you send the notification. Comparing cloud messaging options. Very interesting to know actually, because here we really talk detail about Event Grid, Event Hubs and Service Bus. Each of the messaging services that are used in the cloud have distinct use cases. Storage queues and Event Grid are both serverless services that are ideal for both simple and scaled out workloads that don't have serious ordering or consistency requirements. If a workload does have strict requirements around consistency and order, the service bus service offers a more expensive and complex alternative. The Event Hub service is unique in that it's designed for streaming data that needs to remain consistent across multiple consumers. So you have queue storage, which has supported advantages are communication within the app, individual messages, queue semantics, polling buffer, simple and easy to use, pay as you go model. Event Grid is also pay as you go model. Communication between the app and organization, individual messages, push semantics, filtering and routing for Event Grid. Event Hubs, many messages. The difference between Event Grid and Event Hub is when you have multiple messages in millions, then Event Hub is good, and it's low cost depending comparatively to Event Grid. But these two are serverless, queue storage and Event Grid, but Event Hub is big data. And same with service bus is for enterprise level messaging, which is instantaneous consistency, strict ordering, Java messaging, service non-reproduction, repudiation and security, geo-replication and availability, rich features such as deduplication and scheduling. So depending on your requirement, you can use any of them. So to review, in this video we talked about Azure Event Grid, Azure Event Hubs and Azure Notification Hubs. I hope you liked it, and thank you for watching. Please like, share and subscribe. In the next video I'm going to talk about develop solutions that use messaging. So this video was develop event based solutions, and next video is about develop message based solutions. So if you are interested in learning message based solutions, then please subscribe, and so that you will receive the notification, and please press the bell icon so that you receive the notification about new videos. I'm going to cover more on Azure 203 later on, because I'm going to create also some workshops and real life demos. So I will have a workshop about Azure 203 or Azure 204. So please stay tuned, and please like, share and subscribe. Thank you for watching. Bye.